Well, hi ho, neighbors. Today we're going to talk about inverse functions. And so we're going to talk about what is the inverse of f of x. Perhaps you remember this from algebra 2, but let's take a look at a function. So here we have a generic function, and if you remember, what we're going to do is we're going to switch the x's and the y's. Well, where's the y? Well, remember y replaced f of x, and so what we're going to do is we're going to interchange x's and y's, as we have shown here. All right, and then what we're going to do is we're going to solve that for y. So as you can see, we subtract 1 from both sides, and then we continue to scroll down. We divide it by 2 on both sides, and so a half x minus a half. This we refer to then as f inverse. We use this notation here with the exponent looking like a -1. Or actually the -1 looking like it's an exponent, let me say that correctly. But this is what we would say is the inverse. And if we were to graph that, it looks like this. So we get this graph. And so if you'll notice here, we have a point 1, 0. We swap that around, the x and the y, we get 0, 1 right there. Notice right here where they intersect, the x's and y's are the same. Let's pick this point right here, 3, 1. Which then that means over here we have the point 1, 3. And one last reminder, if we graph y equals x, notice this green graph splits the red graph and the blue graph, the function and its inverse exactly in half. And so those are some things that you should be aware of and remember for a function and its inverse. Let's take a look at one last example. So we're going to consider what's the inverse of f of x equals x squared. And so we swap the x and y here. X equals y squared. And then we're going to solve for y. But when we do so, we take the square root of both sides. But if we take the square root of both sides in an equation, we have to add plus or minus. So we get y equals plus or minus the square root of x. Well, now let's take a look at that. Let's see if there's a small problem with it. So you have here the red graph. That's the graph of the function. Okay, and the blue graph here is the graph of the inverse. But unfortunately, the inverse is not a function. So what we do, is we want the inverse to also be a function. So what we're going to do is we're going to restrict the domain. Okay, so we're going to restrict the domain. So on Desmos, what we do is we restrict our domain to be x is greater than or equal to 0. And then what that does for us is we can eliminate this one. And so now we have this red graph that is 1 to 1. We have this blue graph that is its inverse. Okay, so we have those points that are there. Let's pick this point right here. That's 2, 4. And on this graph here, we swap the x and the y. That's 4, 2. All right, so let's go back to our work. Okay. Again, like I said, we haven't done anything wrong, but we cannot find this inverse. We must restrict. Oh, what's going on there? We must restrict the domain to 0 to infinity. That's an infinity sign there. All right, and that makes it a 1-to-1 function. Okay, we've got to restrict the domain. And so what that does is then it takes this part off here, and our f inverse then, f inverse of x equals the square root of x. All right, so this inverse, when we restrict the domain, is this here. All right, now speaking of domains and ranges, let's talk a little bit about the domain and range of the inverse function. So let's continue this same exercise and let's go back to our graph. And so if you'll notice, all right, I'm going to type this out here. I'm not going to use any Maybe I will. Let's see. All right, so the domain of f of x is 0 to, I can't do the symbol, infinity. All right, but notice our range. Oh, that doesn't like that. This isn't a very good example of f of x is also, it's also 0 to infinity. All right, and so if you'll notice, okay, when we do this, the range, it doesn't like that again, so let's do this appropriately. The range of f inverse, I'm going to use that, is the same thing, 0 to infinity. And I wish I wouldn't have done this, but I did it. And the domain of f inverse is 0 to infinity. All right. So let's change this up just ever so slightly. Let's do this. Let's add 2 to our graph. Let's add 2 to our graph. Okay, so now what that does to our inverse, and you can work this out, but it makes that to be minus 2. So notice now we have 0, 2, and we have 2, 0 here. We have the point 6, 2 on this graph right there, and the point 2, 6 is on that graph right there. Now, what have we noticed? Our domain still stays the same. Our domain stays the same, but our range now we've pushed up 2. Okay, but look at the range. Notice our bottom y value here is still 0. Okay, but our domain we've pushed right 2. So notice the way I've written this. This one here, this first one, the domain matches up with this one here. They're both 0 to infinity. And the range here is 2 to infinity, and the domain is also 2 to infinity. So all we've done is we switched the x's and the y's. So let me summarize this. So if you'll notice, the domain of f of x matches the range of f inverse of x. They're exactly the same, guys. Once you know the domain of f of x, you automatically know the range here. And the range of f of x matches the domain of f inverse of x. So once you know the range of f of x, it's this domain. Or oftentimes we will know the domain of f inverse. Sorry, the domain, we'll know this one first, and then that allows us to come back here. We'll talk about that in class. So, hey guys, I appreciate you watching. I hope this makes sense to you. It's just bringing stuff back from Algebra 2, I believe, but sometimes that's a struggle. So, hey, thanks for watching, and go Cards.